We can further extend find by using some of its optional parameters. Optionally, we can supply two additional arguments to the find method, start and end. By default, if we include one number, Python will interpret it as our start number, and if we include two, it'll interpret the first one as our start number and the last one as our end number. These are also keyword parameters, so instead of just putting the numbers at the end, I could instead say start equals 5 or end equals 10. But if I leave off the keywords, it'll just interpret them in the order they are in the declaration of the method find. If that was confusing though, don't worry too much. Just know if you supply one number, it's the start number, and a second number, it's the end number. What these arguments do is tell find where to start searching inside of the target string. On line 4, if we search without these arguments, it finds the first instance of CDE, which is why it prints 2. On line 6 though, we tell it to start at index 5, so it doesn't start looking until the 5th character of my string. That means it's only looking from here until the end. It ignores that first instance and instead finds that second instance and prints that the index is 7. If we supply 13, then it actually starts searching past the last index of CDE, and so it actually doesn't find anything. There are no instances of the string CDE after index 13 in that string. We can also use this to specify only a portion of the string to search. So here, it'll search from character 4 until character 10. As a result, it's going to find the second instance of CDE. Now, of course, that's the same thing it found when we just started at 5. So you might wonder why we need that last argument. The reason is that sometimes we won't care if a string occurs after a certain point. So here, for example, imagine we only wanted to see if CDE occurred between 3 and 6. Well, it doesn't, and so it prints -1. But if we had left off the end, it would have found the index of CDE at 7, and it would have printed 7 just like it did twice before. Now, as I said, find only returns the index of at most one location of the string that it's searching for, but we can use it to build a longer list of appearances by using a loop. So this code creates the string called myString and creates a find string with the value CDE. It's going to look for CDE inside of myString. Now we can eyeball this and see that it happens quite a lot. It happens here, 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 and here. So 5 total instances. So what we're going to do is start by finding the location of the first instance of CDE. So myString.find findString finds the first location of CDE inside myString. And as we can see right now, that's 2. So current location is set to 2. We're now going to run a while loop as long as current location is greater than or equal to 0. The reason we'll do this is that when we can no longer find another instance of the string we're searching for inside myString, then that find method will return -1. At that point, current location will no longer be greater than or equal to 0, and our loop will terminate. For starters though, right now it is, and so we enter our loop, and we print that it was found at whatever current location currently is. Right now current location is 2, and sure enough, we found a CDE starting at index 2. But next we're going to do something a little bit clever. We're going to search for the next instance of CDE, but we're going to start at the location of the current instance plus 1. We found 1 at 2, so we're going to start at 3. That ensures that we're going to skip the instance that we already found, and we're only going to search from there to the end of the string. Sure enough, if we start at 3 and search to the end, we find another one at 7. And so now, current location has the value 7 instead of 2. Our loop is done, so it jumps back to the top and asks, are we done yet? Well, we're not done yet because current location is still greater than or equal to 0. And so our loop repeats again. It again prints that another location was found at 7, and then again updates the value. Now it's going to start searching at 8, and from 8 to the end, we find another instance right here, which is actually at 27, which we'll see in a second. Now current location is 27. Our loop is done. Jump to the top. Are we done yet? We're not because 27 is greater than 0. Rerun the loop. This time, start at 28, search to the end, find another one at 32. The loop is done. Jump to the top. Are we done yet? 32 is greater than or equal to 0. Run again. But now our result is interesting. Now we're going to start, when we run line 11 again, at 33 and search to the end. But there are no more instances of CDE. So searching for findString inside myString starting at 33 yields no result. So now current location has a value of -1. The loop is over. Jump to the top. Are we done yet? Well, now we are, because now this logical expression is false. Current location is no longer greater than or equal to 0, because now it's -1. So we've now found every location of CDE inside myString. Now notice what happens if the string we're searching for does not actually appear anywhere inside MyString. When we run line 4, MyString.find findString will go ahead and return -1. So current location is now -1. Then when we hit our while loop, it says to do the indented code while current location is greater than or equal to 0, but current location is already not greater than or equal to 0. So our while loop never runs, which is why there's no output. If we don't care about the actual indices where the string appears though, this can be a bit easier. Just like string has a find method, it also has a count method. The count method will count the number of times the string in parentheses occurs inside the given string, or inside the string calling count. So here once again, we're looking for CDE inside MyString. It occurs 1, 2, 3, 4, 5 times, and so it prints that the count of CDE is 5. We can also use the same start and end parameters that we used with find when we use count. So if we had included 25 as an argument, it would have started searching at 25, which was somewhere around here, and it would have only found 2 instances instead of 5. Similarly, if we had put both 3 and 11, it would have found only 1 instance, because that's the only instance that occurs between the indices 3 and 11.